So, what do the graphs of these trigonometric functions, sine, cos, and tan, look like? First of all, starting with sine, we do have a few defined intersections, such as one at 90 degrees, the other at 180 degrees, and then another at 270 degrees and minus 1, and 360 degrees and 0. So what you have to remember is that a graph of sine starts off, the basic graph of sine, to be precise, starts off from 0, or in other words, the midpoint in this case. And the shape of the graph would look something like this. This is a sinusoidal graph. Then moving on to the graph of cos. The graph of cos starts off from the maximum point. So, and then moves on to the midpoint, then goes to the minimum point, and then from the minimum point it starts rising again. Goes to the midpoint, and finally again to the maximum point. And the graph of cos would look something like this. Moving on to our last and final graph of basic trigonometric functions, that is tan. So for tan we have two lines at 90 degrees and 270 degrees. I prefer that you make them dotted like I did, and you should make them. You should make them. So the graph of tan, the basic graph of tan starts off from 0 and looks something like this. These two lines never meet, but it looks as if that this line continually approaches this line, but it will never meet. It will go up to infinity. This is because these lines are called asymptotes. That is a straight line that continually approaches a given curve, but the curve and the line do not meet. And if you were to put tan 90 and tan 270 in your calculator, you would get a math error. Then continuing the graph of tan, the second part of the graph of tan looks something like this. The asymptote again plays its role, and then finally we have a defined intersection at 360 and 0. The asymptote again plays its role, and this is what the graph of these basic trigonometric functions look like. And also notice that ASTC also plays a role here. Just a second. So we have ASTC. How it plays a role can be realized by the fact that if I were to draw dotted lines at 90 to 70, 180, and 360, you will realize the fact that ASTC is again in line with the graph of sine. That is, the graph of sine is only positive in the first and second quadrants and then negative. Similarly, in the graph of cos, we will draw these dotted lines again, and at 360. The graph of cos is positive in the first and fourth quadrants, and this is again, ASTC is again in line with the fact. Then we have the graph of tan x. We already have two asymptotes. I'll just draw another line at 180. So AS, since this region is negative, and then T and C. And this is also correct because the graph of tan is positive only in the first and third quarter. Alright, then just erase these lines. So these are our basic trigonometric graphs. Moving on, when should you never apply ASTC? You would never apply ASTC at these three set of points. Why? Because these three set of points are in fact defined intersections. Thus, we do not need to apply ASTC and we will never apply ASTC. In these situations, instead we will use trigonometric graph to determine the solution. Let's say for example, we have this. Now, I'll change the color first of all. So in this case, realize that we can shift this minus cos x to the other side, and this is what we have. We can cancel out the cos x and we will be left with 2 cos x is equals to 1, or rather I'll make it obvious, that is, let's just say we have cos x divided by cos x, since one of the cos x goes there. So again, this is how the 2 cos x cancel out and we will be left with the 1. 2 cos x. So we have cos x is equals to half. Since we are asked to find the solutions in this region, we can first of all start with finding alpha. So alpha is cos inverse of half and it is equal to, just a second, it's 60 degrees. So applying ASTC, obviously your graph would look a bit bigger. So we have 60 degrees here and in the fourth quadrant, because cost is positive in the first and fourth quadrant. ASTC. Thus we have x is equals to 60 degrees and 360 minus 60 degrees. And the solutions for x are 300 degrees and 60 degrees. Now note, whenever in an trigonometric equation a trigonometric function is cancelled off, that function is always equated to 0. I repeat, like in this case, we had a trigonometric equation and a trigonometric function was cancelled off. Then we must equate this trigonometric function to 0. Cos x was cancelled out, thus this should be equated to 0. So once you equate this to 0, we also have to solve for x in this case. And this is not our final answer. Thus, since this is a defined intersection, I need to make the graph of cos x. I'll just copy this in this case, paste this here. So, cos x is 0 at 90 degrees and 270 degrees. Thus, my answer for x would be 90 degrees and 270 degrees. So. My final answer is x is equals to, in ascending order, 60 degrees then 90 degrees, 270 degrees, and finally 300 degrees. This is my final answer. And again, this is a very important one. Let's just say in this case, again, we can start off by either cancelling two, two functions, or instead there is another alternative method. Let's say, for example, I take sin x common. In this case, I did not have to cancel out anything. Thus, I have sin x is equals to 0 and sin x plus 1 is equals to 0. So, so I can shift the 1 to the right hand side, and again 0 and minus 1 are defined intersections. Thus, I need to make the graph of sine. I have already made this, thus I'll copy this and paste this again. Alright, so sin x is equals to 0. Sin x is 0 at, this is the graph of sin x again, and sin x is 0 at 0 degrees, 180 degrees, and 360 degrees. What's the range? Let's just say the range in this case is x is between x is between 0 and 360 degrees, not inclusive. Thus, sin x was 0 at 0, 180, and 360. But since the range is not inclusive of 0 and 360, reject. Then, for sin x is equals to minus 1. Sin x is minus 1 at 270 degrees. And our final answer for x is 180 degrees and 270 degrees. Alright, this will work too. Aesthetics. Then we have our last assignment. Again, let's just say I do this with both methods. The first method is cancellation, which I won't advise because there's always a chance of making a mistake. So I shift this to the right hand side. So my equation looks something like cos x is equals to 2 sin x cos x. So I'll shift this cos x to the other side to be multiplied to become the denominator instead. So cos x over cos x and 2 sin x. The cos x cancels out with the cos x in the denominator. Thus I'm left with 1 is equals to 2 sin x. And I have sin x is equals to half. But I should also remember that cos x was cancelled off and I must equate cos x to 0. Whichever trigonometric function is cancelled off, I always need to equate that to 0. But let's now consider method number 2, which has significantly less chance of error since it does not involve cancellation but rather only taking common. So I'll just write preferably. So method 2 would look something like this. This is my original equation. Instead of cancellation, I'll just take cos x common. I'll do this with red, and we have 1 minus 2 sine x is equals to 0. Then I'll simply equate both cos x to 0 and 1 minus 2 sine x to 0. Simplifying would again give me sine x is equals to half. So this is not a defined intersection. I need to solve for this first. So alpha is equals to sine inverse of half, and sine x is equals to half at 30 degrees. You should also remember this from the table of trigonometric functions, which has intersections as at 30, 45, and 60. You should also remember that table. I'll cover that up in the next few lectures. So once we have alpha as 30, the graph sine is positive in the first two quadrants. So we have a 30 here and a 30 here, ASTC. Thus we have x is equals to 30 and 180 minus 30. X turns out to be 30 degrees and 150 degrees. This is not our final answer, so this let's not box this up. Moving on to cos x. Cos x is equals to 0. This is a defined intersection. I'll move up and I'll just copy this graph right here. Alright. So cos x is 0 at 90 degrees and 270 degrees. Thus I have x is equals to 90 degrees and 270 degrees. Was I given a range in this question? Yes, I was. But alright, so my answers are in ascending order again: 30 degrees, 90 degrees, 150 degrees, and 270 degrees. Always leave your answers in ascending order. So this is my final answer. And this is and these are the situations when a few of the situations when you never need to apply ASTC, instead make a graph, any one of these graphs or any of these graphs. And this is Ace the Levels signing off.